check it's recording from the right channel. Yep. Okay. All right. So what we'll do today, I think my voice is a little bit funny today because of the cold. I promise you, it's not anything super nasty. It's not a flu. It's just a regular cold. Is to take a look at the serialized, program. I'll first explain what it does, why it is useful, and then I'll also explain the algorithm itself. You don't have to truly understand the algorithm of something like this because it is a little beyond the scope of this class. On the other hand, to some of you, maybe it will serve a purpose later on and say, oh, okay, so this is one way we can solve a problem. Okay, just want to point this out. I think they changed this message from from Monday, maybe not, but it's now working for Mac and Windows, and they will get it to work for Internet Explorer coming soon. I think this part is new. Support for Internet Explorer is coming soon. Last time it just said it doesn't work, so now it's saying, yeah, we're on it, we're working on it. Because I guess too many people only have Internet Explorer installed on those machines, and for whatever reason cannot install alternative browsers, and kind of stuck at this point. So anyway, just want to show you this message because it's kind of important. And what we'll do is take a look at this particular project. This particular project is called Serialize because I make use of lists of pairs a lot in order to store all kinds of information. In fact, I want to use one single global variable in all of my programs to store everything from configuration to user data, things that I have to put into TinyDB, because this way it's easy for me to store everything, and also it's easy for me to pass information along from one screen to the next. But we're still doing okay so far with the concept of using a single list to store everything. Or just about everything, okay? May not be everything, but the concept of a list can be very helpful because a list is like a directory, a folder in files, okay? A single variable is like a file, okay? Well, a file is useful by itself, but it's only one single file. A folder, on the other hand, can contain other folders, and also it can contain files, and that's why the concept of a folder is more important and more useful than the concept of a file, because it is inclusive, it can be nested, it can be hierarchical. And for the same reason, I like lists because I can create a list. Let me just show you, the list that I use as a test in this case. Okay, so here we have, a little test case using a particular list. So this list has only two items at the top level. But the first item of that list is a list itself, whereas the second item is just text, and I'm just testing whether I can treat parentheses correctly in this case. The embedded list is a list, but it also has two items. But in this case, the first item is just plain text. It's plain text or numbers are like files. They cannot be broken down any further. Well, sort of, but not not using the list concept. And then the second one is a list itself. It has a string as well as a number. So if I want to draw this out as a picture, let me just use a marker and draw this out as a picture. So what I have here is kind of like a folder, and then the folder has two items. I mean, this is not going to be very fun because it's going to look almost exactly the same as what you see on screen here. The first item is a folder itself, and it also has two items. The first item is some kind of text here, and then the second item is again a list. Okay, so the second item has some additional text here, a particular number here, and then the second item of the top level list is also just some regular text. So this is the structure of the list that I'm dealing with here as an example. Are we doing okay so far with the structure of the list? How we can have a list to contain additional list, just like a folder can contain folders. Is that concept okay?
You need something up there. You need something up there.
Something up where?
on the top line in the middle, you need some identifier there.
This is a folder.
Yeah, need some identifier there to reach that point.
So we have 3 folders here, but one folder contains another folder. This folder also contains the other folder.
Do you need 3 names there to get down to the bottom floor?
No, there are no names. These folders
No
are not
tags?
named.
No series of tags to get down to the inner node?
No.
Alright.
The first list, the top level list, has one component that is a list, and the other component is a file. The second level list has one component that is just regular text, and then the second component is a list. The third level list has 2 components. One component is text, and the other component is a number.
You have to identify those at first level and second level. You have to say that.
I have to say yeah. And in this
You
case,
need a
there are
tag to define as the first level and the second level.
no, there are no
third level.
tags. You can see from how the list is created. There's no tag in this case. Okay. So why do I want to deal with lists? Well, the reason why lists are so useful is because in a single list, I can now store just about everything that I want to store with an application, which simplifies the whole process of passing that information along to another screen, or to pass it along to TinyDB to store and also to restore the entire list. Okay, that part I have shown already using the DBT diary card application. Is already shown how useful that concept can be. So it is nice to be able to use a list, but there's one limitation with list that I did not overcome in the previous class. I can pass a list along from anywhere within the screen to anywhere else. Okay, I can use a global variable. I can also pass a parameter to a procedure or a subroutine, and that way I can pass a list around using in the same screen. I can still pass a list along from one screen to another screen of the same application. I can do that because I have in the control blocks here. I can use this particular one. Open another screen with start value. The start value can be a list, and that list can be passed along to the other application. The other application can get that list just by going to get start value, and the entire list will be there in the other screen. So that is really helpful because I can now pass the entire configuration to a configuration screen, have the configuration screen to do all the modifications of the configuration, and then pass it back to me. The way it is passed back to me is to use close screen with value, and then you specify the list in the result, and then in the original screen I can now go to screen 1 dot other screen closed, and the variable or the parameter result is going to be the entire list. So it's really helpful because otherwise I can only pass one thing at a time. Okay, I can pass either text or a number along, but I cannot pass like a whole gazillion configuration detail to the configuration screen. But now I can. So that's why lists are useful, because every time I pass a list, it can contain any number of actual items in the list. Are there any questions about this part? Why lists are actually very useful, particularly a list of pairs. So those are extremely useful. No questions about that? Okay. If there are no questions about that, I would go back to a project that we started or we looked at on Monday, because I want to point out, why even though it is helpful, there are things that we cannot do. Okay, so I'm going to test help P here, which is the program. This is the app that is requesting help from another app. So we are not talking about screens of the same app. We are talking about a whole different app in this case. App Inventor has Activity Starter to allow you to start up another program, another app in the Android system, and you can still pass things along. Unfortunately, in this case, when you specify the extra value, when you start another activity, you are limited only to use strings, okay, or text information. you cannot pass a general list along anymore. That's the limitation that we ran up against is, okay, we have to convert a list to a string first using, in this case, list to CSV or comma separated value row, and that becomes, a text representation of a string, of a list. But that also has a problem, because if this list here, okay, make a complex list, if it has sublists, those will not be encoded correctly when we have list to CSV row. It can only handle one level of items. Okay? In other words, you can have a list of text or numbers, it will be encoded correctly, but if you have a list of lists, then it won't be encoded correctly. Okay, let me show you what I mean by that. We talked about this a little bit on the other day, but I do want to kind of give you a whole background of why we are doing the program that I'm illustrating today. Okay, so let's say we have a list here. Okay, this is the usual representation of a list. If I have a list that only has the text information ABC followed by the number 45 followed by DEF like that, then I can use the conversion, which is list to CSV row, and that becomes a row. Basically in text it's just a single line, and it becomes ABC, comma 45, comma, and then DEF, which is not a problem. Okay, so in this case, because the list only contains simple items, list to CSV row as a block does the conversion just fine, and then on the other side it can reverse the operation just fine too. But what if I have a list of pairs? Now we have a problem, because if I have a list of pairs, that means each item in the outermost list is a list itself. So now we have, let's say this is ABC and it has a particular value of 12, and then we have another item which is also a pair, which means it is by itself a list, and this one has XYZ and has a value of let's say tag here. Okay, it doesn't matter. Okay, so let's say this is the list I want to encode. I can still use list to CSV here, but it's not going to do the conversion correctly, because out of the conversion, it will give me something like this. It will give me ABC 12 close paren as the first item in the comma separated value row, and then the second item is XYZ tag in parentheses. Even though it looks right in this case, because we have two items and each item seems like a list, it does not get interpreted correctly from the other side. So if I pass this along to list from CSV row, it will give me back a list of two items. But the first item is no longer a sublist. It becomes a string that has ABC and 1, 2, and a space in between as the first item. And then the second item becomes the text of just XYZ tag here, which is not the same. So if you look at this thing here, it is not the same as the original item, because I lost the embedded lists. And that's the limitation that I ran up against on Monday. Are we doing okay so far in terms of those concepts? Some of you may understand this because you have taken other classes like data structure, so you understand what an embedded structure is or what an embedded list is. If you don't understand, that's okay. Okay, it's not a problem in this class. I just want to point out that the conversion does not work correctly in this case. Is that okay? Okay. So that's why the approach doesn't work. In other words, I can do a simple list using the extra value and use list to CSV row in order to make one app inventor app to call out to another app and say, hey, I need you to do some processing for me, and here is a list. Okay, and then the other side can get it correctly as long as the list does not contain other lists, does not contain sublists. And that's a limitation. I really do not like that limitation at all. I want to be able to pass a general list from one application to another application, and then the other application can pass it back to me, as a single list. Okay, So does everybody understand, the background, what type of limitation I was running up against on Monday that kind of prompted me to write the code for today? Okay, because I want a method that works on list in general. I can have a list that contains another list that contains another list that contains another list, and the list will be reconstructed correctly on the other side and as well as on this side. Okay, if that is understood, now we can move on to what I did to do the encoding. So I'm going to switch the project to the project that I was working on earlier today, that was showing earlier on today. The designer view is really simple. Okay, this is just a proof of concept, so I didn't even waste time to make the first screen fancy. It has two buttons. The first button is to serialize, which means I'm turning a list into its text representation, and then the second button is to take the text representation of a list and turn it back into a list. Okay, so this way I can check both direction. Can I convert to text? From text, can I convert it back to a list? And when we look at the blocks, the initialization of the screen is very simple. I'm just making a fairly complex list here, and assign my global variable called a list to it, and then I change the text of my first label to the quote-unquote representation of that list. Okay, so that's not really complicated. Let me just go ahead and start my virtual machine so that we can now take a look at how this works. And we'll start small one. So we have our virtual machine up and running. We just need to switch to this tool. See if I can talk to the device. It's offline. That's okay. I'm going to download the app to the computer first. A bit slow today, but that's not too bad. And now I'm installing that particular app to my virtual machine. So that's called serialize. And switching back to my virtual machine, I can now show you, the first step, what it does. Okay, so we have serialize here. Okay, so the first thing it does, when it initializes the screen, is to show you the list, the quote-unquote complex list, using the normal conversion. Okay, I'm using some really kind of funky test text here, because the first one has spaces in between, the second one has commas, and then the last one has parentheses. So those are all kind of special characters that can be problematic. Okay. Alright, so the next thing I'm going to do is to click the serialize button, and you can see the second label is now getting some really awkward text here. It says text %20 with %20 space, and then but for those of you who can kind of read the encoding, especially when you know what is URI encode, you can probably tell, oh okay, 20 is space, 2A is the asterisk symbol, and then 2C is the comma, symbol. Okay. But then it also has some other funky stuff, like the asterisk symbol here, there's a 2 here that are completely missing from the original thing. So what are those things doing here? The second button, called unserialize, which is the reverse of serialization, is going to take this text here and then turn it back into the structure, into the list, so I can double check and compare and see whether it does it correctly. And you can see that the first piece here is identical to the third piece here, which means the application is actually working correctly. It can convert a structured list into regular text. You can now store it into a file. You can send it to another application. You can do whatever you want with it. It's just regular text. But it can take that text and then reverse it back into the structured list. So that's what this program is doing at this point. Okay, so the next question is, what exactly is it doing? I mean, how does it do the conversion? Okay, so let's go back to here and I'll explain how it does the conversion. I can also use mousepad for that purpose. I think I'll just go ahead and use mousepad here. Okay, let's start with something simple. Okay, so we'll start with just a regular text. Okay, so if I have regular text or string of, let's say, tag has a code today. Okay, if I want to store this and quote unquote serialize it, you would say that's easy, right? I mean, it's already in text form, so it doesn't really take anything to represent it. So the serial, after it is serialized, it should just be the same thing. Tag has a code today. Okay, doesn't seem like there's any processing required. Okay, that's easy. Let's try the next one. The next one is going to be a list, but I'll make this list very simple. So this one is just, okay, let's say 34 and 56 as 2 numbers in the list. Now I want to serialize this particular list. Okay, so how am I going to represent a list of 2 numbers? That doesn't seem hard at all. I mean, you can just use a comma to separate the 2 values, just like with list to CSV row will do exactly the same thing. You just say, oh, first item of the list is 34, second item of the list is 56, and that's it. So when you go through unserialize, which is to reconstruct the list, then it becomes 34 and 56 again. But this approach has one implication. The implication of this approach is, hey, these things are special. Okay, the double quote symbol is special now because it is used to enclose the text between the items, and then the symbol comma is also special because it is now acting as a separator between the items. Is that okay so far? That the comma has a special meaning when we use this particular method to serialize. Okay, well, the first thing I want to do is to say, I don't want the double quotes to have any special meaning. Okay, well, if I don't want the double quotes to have any special meaning, that means I can go back here and say, okay, let's get rid of the double quotes. 34, 56, now we don't have any double quotes. Okay, that's fine. But comma still has a special meaning. I still need a particular symbol to represent, hey, this is the separator between the items on the list. But that's going to be a problem because what if I want to serialize the text here? Okay, so what if I have the text here, tag who has a code today is still teaching. Okay, so what if I want to serialize this? Well, now we have a problem because when we serialize this using this particular method, remember I got rid of the double quotes already. So without the double quotes and I serialize this whole thing, it becomes just that. Because I don't have the double quotes and it's just a regular string, right? But when I go through the unserialize, the reverse of the operation, unserialize will look at this thing and say, oh, okay, commas are separators. So this is now a list. In fact, this is a list where the first item is just tag. The second item begins with a space, who has a code today, and then the third item is without the comma because the comma is consumed as a separator. would be just is still teaching. That doesn't work, right? Because the symbol, the comma, which was in the original text, is interfering with unserialized when it wants to say, okay, how many items are here? How do I separate the items? So comma needs to be what we call escaped. In other words, I do not want comma to appear in the actual representation anymore. And that's why I have one subroutine called escape to turn all the commas into something else. So how do we get rid of the commas? Well, one easy way is to say, if every time we see an actual comma, we turn it into %2c. Every time we see a comma, we turn it into %2c. So if I do it that way, unserialized will see this whole thing, we'll see this entire thing as, oh, okay, it's one single thing because I don't see any commas here, right? So it becomes just a regular text, a regular piece of text. But when I do the unserialization, I also do not want the commas to be separate, to be represented as %2c. So I can run another subroutine on it and say, oh, every time you see %2c in regular text, replace it with a regular comma. Every time you see %2c, replace it with a single comma, and now I have everything done. So that's why there's a subroutine to do the escaping, and then another subroutine to do the unescaping. Basically to convert 2c to a comma, and convert a comma to a 2c when I'm escaping, and convert %2c back into a comma when I'm unserializing or unescaping. Are we still doing okay so far here? Okay. Okay, great. So now, how do we deal with a list? Well, but isn't this working already? I mean, this seems like I would take it out of here. Well, not quite. Because what if we have a structured list that looks like this? What if we have a structured list that has 1, 2, and then 3, 4, like that? So it doesn't look like a really complicated list, but it is. Because we have a single list. The outermost list is a list of 1 and then another list. If you look at the secondary list, it is a list of 2 items. It has 2 as a number and a list as a second item. And then the third level list now has 2 single items of numbers. How are we going to represent this? Well, let's try our usual ways. Okay, so let's try to serialize this whole thing as 1, 2, 3, 4. But that's not going to work correctly, because when we unserialize, it will just basically say, oh, okay, you have a list of 4 items, so it becomes just 1, 2, 3, 4, which is not the structure of the original list. Even though it has the same 4 items that I want to represent, the structure itself is now incorrect. Am I making a point here? Okay. So I need now a way, I need a way to basically say, oh, wait, this is not a single list. There is a structure to it. In other words, 1 is by itself, 2, 3, 4 is, it's components inside another list. But within that component, 2 is by itself, and then 3, 4 forms its own list. How am I going to do something like that? Well, I can use the parentheses, but I chose to use what we call a postfix notation. Excuse me. Excuse me. Okay, so the way I actually did it is the following. Okay, so I'm going to redo this whole thing here. 1, 2, 3, 4. When I do the serialization, the way I do it is to I'm trying to come up with a good word here. The correct word to use, the technical word, is traverse, but I don't want to use the word traverse in this case. I have a way to visit all of these specific numbers. Okay, but the way I visit these numbers is a little bit different. Okay, so I will still visit the numbers in the same way. Okay, so in the output, it is still 1, 2, 3, 4. But until I tell it to convert things into a list, it doesn't do a single thing. Okay, so the next one is going to be the confusing one. Because now what I do is I will specify 2 and then the asterisk symbol. What it does is when we see, or when the program sees the asterisk symbol, it's basically saying, okay, make a list. Okay, when it sees the asterisk symbol, it means make a list out of the quote-unquote previous items. But the previous items, there are 5 previous items in this case. How many am I supposed to use? Because at this point, I really just want to make a list out of 3 and 4. That's what I want to do at this point. So what this 2 is doing is to tell the asterisk or the make list action and say, oh, by the way, I just need the previous 2 items or the 2 items previous to the 2 itself to form a list. Okay, so this means when I process the asterisk symbol, it will immediately take the 2 to understand how many items prior to the 2 do I want to use to create a list. Well, since it says 2, then I'm going to pick 3 and 4 and make a list out of just 3 and 4. So now I replace the 3, 4, 2, and the asterisk with a single list of 2, 3, 4. And then after that, I have another 2 asterisk to basically say, okay, remove the previous 2 items, make a list out of it, and replace the 2 items with that single list, and 2 asterisk again. And that will basically reconstruct the entire thing back to 1, 2, 3, 4, but in a structured list like this. The second row here, or the serialization, is what we call the reverse Polish notation, which basically means it does not use parentheses, it does not use the infix notation, it just specifies values and operations. But every time you encounter an operation, it kind of knows, what to do with items that are already in store. Okay. Okay, I know most of you are looking at this and go like, what the heck does it mean? Okay, so I want to show you another thing that makes, that to some people may clarify what is the reverse Polish notation. To other people, it may be more confusing than ever. Okay, so it depends. Okay, so let's take a look at a regular expression. It's called the infix notation. So we'll say, okay, x plus y, and then the whole thing times z. And then I want this entire thing to be divided by a plus b. Okay, this is what I want to do as a calculation. Okay, does everybody understand this particular expression here? Okay, I want to first compute x plus y. I want to multiply that sum to z. Then I want to compute a plus b as a number, and then I want to divide the entire thing, x plus y times z, by a plus b. Is that okay? This is called the infix notation. We are all familiar with what we call the infix notation. I'm not going to talk about the prefix notation in this case because it's not relevant, but I will talk about the postfix notation because it is directly related to what we just talked about a little bit earlier. So in the postfix notation, to express exactly the same thing, it becomes x, y plus. Okay? Because the computer will process x and say, I don't know what to do with it, I will put it aside. The computer will process y and say, I don't know what to do with it, I'll put it aside, next to x. And then the computer will encounter the plus and say, oh, I know what to do with plus. I need to grab the previous 2 items that I have seen, add them together, and then that becomes one single item. Is that okay so far? Okay. But I don't know what to do with the sum of x, y, z, x and y at this point. That's okay. Then we specify z. The computer says, I don't know what to do with z. And then we specify the multiply here. Okay, by the time the computer processes the asterisk or the multiplication symbol, we have z, but we also have the sum of x and y at that point. So it only has 2 items available at that point, and it says, okay, use those 2 items, and it will compute the product of those 2 items. And then after that, we'll present A and B to the computer. When the computer processes A, it says, well, it's a number, but I don't know what to do with it. When the computer processes B, it will say the same thing and say, well, it's a number, but I don't know what to do with it. But then when we say plus, then the computer will say, oh, plus requires exactly 2 items. The 2 items before the plus, I'll just add them up together. So at this point, what we have, basically put aside, as results of computation, would be the product from the numerator, and then the sum for the divisor. So at this point, we have to specify a divide, and we're done. This is called the reversed Polish notation, or RPN, for some calculators. Are we doing okay so far with this notation? I will not test you on this kind of stuff, but I just want to give you some exposure to the reversed Polish notation. Is that okay? Some of you.
Do it like that?
Huh?
Why does it do it like that?
There are about 2 or 3 reasons why it's not doing it like that. One, in early days, the calculators are really simple, so they don't want to deal with infix notation. Because as it turns out, to a computer, if you want a computer to understand what this means, it actually is more complicated. And in the early days, in HP calculators, they don't have the resources to parse the infix notation because it is actually more difficult for a computer to parse it. As opposed to this notation here, which to the computer is very easy to process. So that would be reason number 1. And then the reason number 2 is you don't need parentheses. So in this notation here, you need parentheses. And one of the problems that people have had and still have is, what if you put the parentheses in the wrong order? What happens when they're not paired correctly? Then you have problems, right? Because it's harder to see the problem. But in the this is what we call the suffix notation. Suffix means after. In this notation, there are no parentheses. Now, to you and I and people who do not use the postfix notation on a daily basis, to look at something like this and convert it to something like this takes time. Even if you understand the concept, it will still take you time to do the conversion. But there's an entire generation of engineers who grew up with XP calculators. They can do the conversion in a fraction of a second in their minds, and without having to write it out at all. They just look at the equation expressed in the infix notation, and they can instantly convert it to the suffix notation without having to jot down any notes. So it's really just a matter of getting used to it, and that's just what it is. So are we doing okay so far with the infix notation versus the postfix notation? The postfix notation simply means, give me the stuff, then tell me what to do with them. That's basically what it is. So in this case, give me the numbers, then tell me what to do with them. Give me the numbers, tell me what to do with the numbers that I have available. Give me the numbers, tell me what to do with the numbers that are available. And at this point, I have 2 numbers already available. The first one coming from here, the second one coming from here, and then tell me what to do with them to divide. Okay. So if you don't understand this fully, do not worry. I'm not going to test you guys on infix to postfix, conversion. But it is important because this serialization is using exactly that notation. It's the postfix notation of constructing a list. Give me the items, and then tell me what to do with those items. Well, in this case, I give you the 4 items, and then I say, oh, use the previous 2 items to make a list. So that means the 3 and the 4. But 3, 4, 2, and the asterisk symbol will boil down to one single item because it becomes a list, which is a single item. So when I encounter the 2 asterisk here, it will basically take this entire thing, which includes 2 itself by itself, but 3, 4, 2 asterisk is already a list, so it has 2 and a list, which is resembling this part of the original structure. And at that point, I would have one single item still left here. This whole thing becomes one list. And I will say, oh, take the previous 2 items and turn that into a list. And that is when it converts everything into the original form. In other words, the number before the asterisk is just a counter. It's just telling me how many items from the things that I already have should I use to construct the list. Am I doing okay so far, or kind of, this is...
What do you mean, how many items do I have?
Okay, let me give you another one. Okay, so let's make a list of pairs. Okay, so in this case we have last name, Aoyong. We have first name, tag, and then we have phone number. Which is extension 8250 on campus. And okay, let's just deal with this one. Okay, so this is a very typical list of pairs that we can use. So now we can use last name as a tag to retrieve Aoyong. We can use first name as a tag to retrieve tag, and then we can use phone number as a tag to retrieve the actual phone number. Okay, so this is a fairly common data structure that you would probably use in the program. So to serialize this, okay, it will basically say last name, comma, Aoyong. Turn it into a list. So the 2 items from before, turn that into a list. And then it will give me the other 2 items, which will be first name and tag, and turn those 2 into a list. So at this point, it would have 2 lists already, because from here to here, it turns into a list. From here to here, it turns into a list. So now I have 2 lists. But I still have the third one, which is phone number and X8250. And those 2 items should be turned into a list too. So now I would have 3 things remembered, because the first one would be the first pair, the second one is the second pair, and then the third one is the third pair. So now I have 3 pairs already remembered, and I would say, oh, take all of those 3 things, the 3 pairs, and turn them into a list. Make them items in the list. So I would specify 3 because there are 3 items to use to create the new list, the higher level list, and then the asterisk symbol is just saying create list out of those items. So this is how it would serialize this whole thing. And to unserialize is to do what I just said. So it would just reverse the operation and give me the original structure back. Yep.
Is the asterisk a common thing to separate do that, or is that just your convention?
The asterisk as an operator is just my convention.
Okay.
You could use something else. The only thing is, if I use the asterisk symbol to represent an operation, it cannot be inside the text anymore. So that's why the asterisk symbol is also going to be escaped to %2a, which is the ASCII code of the asterisk symbol. The space is actually encoded too, because I don't really like to use space itself. So this space here, would actually be escaped into %20. But that's the easy one. It's just seeing whenever you see space, change it to %20. Are there any questions about this?
What was the end of that sentence? Whenever you see a space, you change it to what?
%20.
%20.
Yep, which is the ASCII code of space in hexadecimal in base 16. Okay, so now that we kind of have an idea of what we want to do, let's switch back into the blocks and see how it is actually done. Okay. Let's take a look at the simple ones first, which is escape is probably the simplest one first. So we'll take a look at escape. There we go. Okay, so here is escape as a subroutine. So what it does is it is just looking for all the quote unquote special characters and replace each special character with the encoding that it's supposed to use to encode that. Okay, so let's take a look at the entire subroutine. I will just focus on different blocks at the right time. So the outer block is saying I'm defining a subroutine so that we can use the subroutine from anywhere. So that's not too mysterious. This block here, the block that I have highlighted at this point, just gives me the ability to use local variables. So I have two local variables in this case. I have result as a local variable to store the string that I'm supposed to return. And then I have a local variable I, which I don't think I actually need to use in this case. So I is actually not used because I have an index later on. Okay, and then we have the do return block here. The do return block has two sockets. The first socket is for code, and then the second socket is to specify a single value that it will also return. And then this block in the inside is called a for each block. What it does is it has a index. In this case, you can rename it to whatever you want, but it has a particular variable that is local to this block here. And the purpose is to go from 1 to whatever is in the socket of 2 by, each step is going to be specified by the by. So in this case, I'm going from the value 1 to the length of the string, and I will go through, for each iteration, index will be incremented by 1 until it gets to the length of string. Okay, so it's a quick and easy type of loop, similar but not exactly the same as a for loop in C. Okay, but it can be emulated by a for loop in C. If you want to comment this, okay, if I want to add some comment to it, it is just basically saying for each character in str do the following. That's basically all that is doing. Okay. So this is a nifty tool to add comments to a block, just so that you can you know what you were doing with a particular block.
Question?
Yep.
Can you do that in one? Add a comment?
Yes. Yeah, in one you can right click on a block, and I think it will give you the ability to add comments. I'm not 100% sure because I have not used App Inventor 1 for some time. You can give it a try and see if it works. Okay, now we move on into the kind of big, if then else block. Is it the fluorescent light or the screen? It's the light. You can switch the banks in it. So it doesn't blink. Okay, so for each case, okay, it doesn't have a switch statement in C or in Java, but I can emulate the effect of a switch statement just by doing this. So each condition of the conditional statement is a block that looks like this. It's basically an equality check. What is it checking? Well, it's checking a single character out of the string. Segment is basically saying, okay, where am I getting this segment? What is the original string? Where do I start, and how many characters should I use for this particular segment? And then this specifies the equality check, and this is just saying, okay, I'm checking this against a % symbol. The % symbol itself is a problem, because if I use %20 to represent a space, what if the original text itself has % and then followed by 2 and then a 0? Then it will misinterpret it as a space, right? If I don't do something special about it. So that's why a % symbol is as quote unquote escaped into %%. Every time I see %%, then I know, oh, it just means a single % in the actual text. Okay. And then I do another test with the asterisk symbol. The asterisk symbol gets replaced by %2a. So the result is basically the string that is being returned. It is a concatenation, using the join operation here of what I have up to this point in result, and then concatenating with the representation, in this case for the asterisk symbol. The space symbol itself is also escaped, even though it's not actually needed. I did it anyway. So the space symbol is replaced by 20 after a percent symbol. A comma has to be escaped. It is represented as %2c. And then for everything else, I would just say, well, whatever it is fine. Okay, like, you know, everything from A to Z, 0 to 9, you know, all the other punctuations, anything other than a space, a comma, or an asterisk would just be by themselves. I mean, they're just exactly the way it is, so I'm just appending that. When this is all done, I would go to the result socket here to return result as a local variable as the value that I'm returning for this particular procedure, or subroutine if you will. So that's how I do the escaping. To unescape is the opposite. It's a little bit more complicated than escaping because I cannot use the for next block. So to unescape, which is the reverse of escaping, this is what I do. I am given a string that has all the escaped characters. In other words, it has %20 for a space, it has %2a for the asterisk symbol, it has %2c for the comma, it has %% for a single percent itself. So this is what it does. Okay, this is the outermost block to define the subroutine. This is the next block to define my local variables. In this case, I is actually used. And then we have a do return block here so that we can perform some operation and then return a particular value. And this is the inner loop. So instead of a for loop, I have to specify a much more general while loop, because sometimes I would take out multiple items or multiple characters at the same time. So I can no longer just say, you know, do it one by one, because sometimes I have to skip by 2, and other times I have to skip by 3. So the first thing it does inside this conditional statement block here is to say, oh, am I seeing a percent symbol? Because a percent symbol signifies to say, hey, you know what? Something may be special after this, so we may need some special processing here. Anything that is not a percent symbol, I just say, okay, that's fine. Just stick it out to the output because it is not special. I don't have to do any special logic about it. Now, if it does start with this %, then I want to check the following, because I want to check whether the next thing is also a percent symbol. You can see that this block may seem identical to this block here, but they are not, because the start location is I in one case, but it is I plus 1 in the other case. In other words, this block is now checking, okay, we just saw a percent symbol. Let's check whether the next character is also a percent symbol. Because if that is the case, you know what we should do? We should just say that, oh, combine the 2 percent symbols into one single percent as the output of this string. But in order to skip the 2 characters, I'm going to add 2 to I, so we are now skipping %% to the next character for interpretation. Okay, the rest is pretty much the same thing. This one is just saying, okay, we just saw a percent symbol. Let's check after the percent symbol whether we saw 2a. Okay, if it is 2a, then we will say in the output, just give me a single asterisk symbol, but to skip to the next input character to process, skip by 2 characters. 20 is replaced by single space, and then skip by, I made a mistake here, didn't I? Because this needs to skip by 3, not skip by 2. I've not tested this because I've never put an asterisk into an actual string, so I have never triggered this particular error. Same thing here with the 2c, it is replaced by a single comma. But for anything else, we'll just say, well, you know what, there's nothing special here. Just take whatever it is and then put it into the output. That's all we need to do. Okay, and this block here is corresponding to the else of the outermost conditional statement, which is basically saying, but what if we are not seeing a percent symbol to begin with? Well, in that case, it's easy. There's no special processing. Nothing is escaped in this case. So whatever we see is whatever we output in this case. So that's the unescape subroutine. It reverses the operation of escape. Are there any questions about escape and unescape? Fairly, I would say standard, type of processing, nothing too special about it, okay? It's just text processing, one by one, if I see this, I, output something different, or if I see this, I would say, oh, okay, this is an escape, symbol, let's do the whole thing and convert it back into one single character, okay? It's not very general purpose, do not use this for URI purposes. It doesn't do the same thing as a URI encode. That one is far more general than this one. This one is just specialized enough just for this particular purpose. Are there any questions at this point? Okay, if there are no questions at this point, let's go ahead and take a look at serialize. Okay, in other words, how do we start with a single list that can be complicated and convert it into the text representation and just a regular text representation? Okay, and you can see that serialize is actually a bit shorter than unescape or escape itself. Isn't that kind of funny? Because you would think that this has to be fairly complicated, but it's not. It's because the way we look at things. Okay, so let's take a look at this thing first. Okay, the first thing is the subroutine itself. It is called serialize. It has one parameter called thing. So we want to serialize this thing, and as a result, it gives me a single text string. I use my local variable result to represent the result, which is a string. It starts with an empty string, and you have to start with an empty string because if result is unspecified and you try to concatenate something to it, can anyone guess what happens? If you leave result uninitialized here, in other words, if you leave this socket not connected to anything, and then you say, I want to join result with something else, what would be the result of that, of the join operation? It becomes 0 and then whatever you want to join, because when you use a uninitialized variable in the context of join or anything else, 0 is the default value, not an empty string. Okay, so if you want string processing and you have variables that you want to initialize, always initialize those variables to an empty string, because if you don't, it is the same as the number 0, which is not what you want. I found it out the hard way, obviously. The best way to learn something is to step on it and go like, ouch. Okay, next time don't do it. Because if somebody just told me and say something like blah 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 blah, uninitialized means 0, it just comes in here and goes, I won't remember it. But now I remember. All right. So let's take a look at the body here. This is just a do return block. It's just it's just needed because we have some operation to perform, and then we have to specify a return value. So by itself, it doesn't do a whole lot. This is the part that is interesting because it is a single conditional statement, and you can see it's not even very complicated. If I just take one step out, I can display the entire conditional statement. So it's not complicated, and that's the core of this entire subroutine. Okay, the condition it evaluates is whether thing is a list. Okay, thing is the input, the thing that I want to encode. So it's asking, is that a list? Well, let's handle the case when it is not a list. If it's not a list, it would just say, okay, fine, escape it. Okay, in other words, it'll turn all the asterisk symbol, space, and comma, and the percent symbol itself into percent blah blah blah, so that those symbols do not appear inside the encoded version. That's all it's going to do, and return it. But what if it is a list? Well, if it is a list, then it will say for each item in the list, do the following. Okay, this is a control block that is really handy because if thing is a list, if this thing here is a list, this block here allows me to examine each and every single item in the list without having me to specify, oh, look at the first one, look at the second one, look at the third one. It just automatically make item, which is a local variable, to each item in the list, so I can, it's just a really nice, shorthand. So what I do for each item is really simple. Because what I do is I just say, oh, join every single item here, okay? Join all of the following. Whatever I have in result already, let's start with that, okay? That's the first item. The second item is saying, if result itself is blank, is an empty string, don't do anything because I don't need a comma to separate from nothing. Okay, that's what it's doing. But on the other hand, if result is not empty, in other words, there is something in result already, specify a comma so now I can separate what is following from whatever is before this. And then here comes the fun part. The fun part is this item in the list here can be a string, like a name, can be a number, can be a list all by itself. So what am I going to do with it, with all these special cases? I don't know, but I know someone who can process it. Who can process that? The same subroutine, serialize. Because that's what serialize is supposed to do, right? You give it a thing, it gives you the text representation. So with this item in the list, I'm just saying, I don't know how to do this, but I know someone who can do it, which turns out to be myself. So I'm going to call serialize again, but this time not on the original item, just on that one single item. Whatever it returns as text, append it here. And this is called recursion. If you have taken, I think, CISP 430, you should be somewhat familiar with the concept of recursion. If you have not taken CISP 430 and you're planning to take CISP 430, this is a preview of some of the fun things you can do with recursion. How many people think you have a kind of general understanding of what this means? Well, that's very nice. Okay, this is actually very useful as a concept. So after the for each loop, in other words, now I have a gigantic thing, okay, which is which would be comma separated things, okay, from all the items within this list itself. What I need to do is to specify, oh, but now I need to say retrieve that many items and generate a list from those items. So once again, I'm starting with the string that I have up to this point. I specify a comma here because that's a separator. Then I specify the number of things or number of items in thing, which is a list. Okay, because that's the number of items that I need to create a new list. And then use another comma here because it's a separator. And then I use the asterisk symbol to say, okay, make a list now. Because I have just specified all the things, I have just specified the number of items that I need, and now we can go ahead and make the list. So this is how I generate the text representation from a structured list. And then the rest of this code is easy. It's just returning the result as the string that I have been constructing all along. Are there any questions about serialize itself? And by the way, I put this up on the gallery already. If you look for the name serialize, you will find it. That's the name of the project. I put it up on the gallery already. Huh? Yeah, I'm gonna have to update it because of that one fix. Okay, so if that's serialized, what about unserialized? In other words, how do we reverse from a text representation back into a list? Well, that's about here. That's the first one, which is clunky. That's why I didn't like it. I rewrote the entire thing to the second one. Okay, this is unserialized, which is surprisingly not recursive. Okay, this is actually non-recursive, unlike serialized itself. Okay, so we'll go ahead and take a quick look at this. I know some of you are going like, I don't want to deal with this. Okay, the outer block, simple. We're just defining a subroutine called unserialized. It is given a string, which has to be a text string. The very first thing we do with our local variables with chunks is the following. Chunk is using the split block here. Basically, we're saying with the input string, use the comma as a separator and chop it up into smaller chunks. And put all of those smaller chunks into a list, which becomes my local variable called chunks. And I have a second variable called stack. Okay, it's the proper term to describe, the place where I stash the computer results. Okay, it's called a stack, which is beginning with an empty stack. So it's an empty list to begin with. And then we specify the do return block here, which doesn't really do anything. And then we'll start with a while test do. I'm going through my chunks one by one. Every time I process one chunk, I will remove it from chunks as a list. So that's why as long as the length of chunks as a list is non-zero, I still have some more to process. That's what this loop is saying, is as long as there's something else to process, keep doing this. So how do I process a single chunk? Okay, I have another local variable here called chunk instead of chunks, because all it does is to take the first item out of chunks and say, okay, now what do we need to do with that? And that depends on what the chunk is. If that chunk is a single asterisk symbol, then we're gonna do this part here, which is basically going to my quote-unquote stack, which is my little stash of computed results, and say, oh, okay, we need to retrieve n, which is the number of items that I have just seen from the previous item on the stack. Let's go ahead and retrieve that many things and create my sublist out of it. And then after that, I'm just, I'm done with that list. Okay? And it becomes a single item, I put it back onto the stack. If the answer is no, if it is not a single asterisk, oh, that's easy. Because all I do is to put it onto the stack and say, I don't know what to do with this. Okay, I'm just putting it on the stack for the time being. And I'll do some processing later. Am I doing okay so far with the explanation? Okay, so it's fairly easy to it doesn't have an operation called pop. Otherwise, it would be even simpler. The code would be actually even simpler to read. And every time I process one thing from chunks, I'm going to remove that item from chunks itself, and that's how chunk is becoming one shorter with each iteration of the while loop, and eventually it becomes empty. And when that happens, I just go ahead and say, oh, the first item on the stack is the result that I need to return. In other words, this would work, serialized would work with a list, but it will also work with single numbers and single strings. Not a problem. It will work with just about anything you can throw at it. So are there any questions?
Are you gonna run it? Are you gonna run it?
Sure. Well, I tried it already earlier, but that's without the fix. So what I'll do this time is I'm going to test it with all the special characters that we have, because in this case we only have space, comma, and let's go ahead and specify something with strings. Let's make it more complicated. Let's make another list out of this. So make another list again. Make another list. There we go. Oh, that's one more %, right? There we go. So we'll see whether it works or not. All right, so let's build. I think we have enough time because I can show you, how you can surgically implant code from one project into your own project, because it doesn't work. Copy and paste only works within the same screen. It doesn't work across projects. So I kind of showed you a little trick to do it. Some people in this class have been doing it for weeks now. Alright, so we installed it. Go back to my emulator. Start serialize. Alright, so my test string or my test list is now, it looks kind of like this. It's kind of complicated. And I click serialize, and I can see the asterisk is the 2 A's here, and then the percent is %%, which is here. And now we run unserialize. And by the way, I have never tested percent and asterisk itself, so it may or may not work, knowing myself. Yep, the 2 A's are not converted back into the asterisk, but the percent is converted back just fine. So I have one little problem with my unserialize not taking care of the 2 A's and converting that into asterisk. I probably just missed that one case somewhere. Okay, let's double check. Okay, this is serialize. Okay, I need unescape. Let's escape. And escape is over here. Okay, there we go. Okay, it checks for percent. It checks for 2A. Oh, but I forgot the length is 2. There we go. Little things. Okay, let's rebuild it and test it again. It got close. I also want to go back to my projects to re-export it so that I can post it again into my gallery. So I'm gonna go to project, export, save. Okay, there we go. Well, first of all, we test the program again, make sure that the asterisks are properly decoded. So go back to the emulator, run it again. Serialize, unserialize, everything is working this time. Excellent. And now we can go to the gallery. They don't have a link to the gallery anymore. So if you want to go to the gallery, you pretty much have to type it in yourself. You can still get to it. It's just that the direct link is not there anymore. I added it, as a different user, and that's why, it's missing from this one. To turn a structured list into text back. And obviously I don't have an image specified yet, so we'll go ahead and take a picture of it. Screenshot. I think most people would look at this app and go like, what is that? Alright, it's online now. Hey, any other questions about this? before I teach you, in the last 5 minutes, how to hack your project, so you can surgically implant something from another project without having to replicate the code using the graphical user interface. All right, so let's go to a text prompt here. I'm doing this in Linux. You're welcome to do it in Windows and other tools. Basically the same technique. Nothing really that much different. So I'm gonna make a folder called serialize, so I can contain all my code over there. And then I use unzip to unzip the file called serialize.aia. In Windows, you may not have the command called unzip, so you might need to change the extension of AIA to zip, and then you can double click it and it will actually unzip it at that time. It's just a regular zip file, so Windows can do it, but it doesn't know what to do with it with that extension. But Linux doesn't care about the extension, so we don't have a problem. Okay, so we'll go ahead and change to source, app inventor, AI, Dr. Tech apps, serialize. And there are 3 files here. The 3 files are screen1.blocky. I don't know what the Y stands for. Does anyone know? No? Okay. Blocky. The second one is for the screen itself. It specifies the screen resources. And the last one is Yale, which is interestingly, is the Lisp representation of the blocks. Okay. So if you look at screen1.bky, it's an XML file, and you can see that with each subroutine, it has its own block. Yep.
Maybe it's a YML file?
YML instead of XML.
Yeah.
I don't know. So when you look at the subroutines, it has its own name. So if I go to serialize as a name, those are the buttons. Okay, this is the name of the subroutine. So the block starts from here. It is a procedure which has a return value, and then inside it defines the name as unserialized2, which is an earlier version. You don't need that one. But everything from here, which is line 417, you go to the end of this block here, matching indentation. That will be the end of the entire thing. So from 417 to 661 is where you want to copy and paste into the destination, the other project. But there's also another file. Did you have to do something to the Yale file too, or not?
No, as long as all the object reference exists with the same name.
It will reconstruct the Yale file?
You just have to have something there, or you either can't reference stuff that's in.
Okay.
Oh wait, the Yale file. What were the files again? It was block file, the str file, or
There's the BKL file,
Yeah.
which contains the blocks, which also includes the coordinates. There's also this file, which is the Yale file, which actually contains the actual representation of the logic of the subroutines. So the question is, do we have to do anything with this one too? Because that's actually the Lisp code for the subroutine.
I don't think so.
Yeah, I don't think so either. So just doing work with the BKY file, should be sufficient. This can be generated from the BKY file, and that's why this file may not need to be edited. But this is interesting because this is the actual representation of the subroutines. Okay, this is the unescaped subroutine. This is actual Lisp code. This is actual Lisp code, which I don't know whether it's run from the perspective of the application, or whether this actually gets translated into Java first and then it gets run. That part I do not know. So whether they have an interpreter to run this code or translate this code, compile this into Java, that's a different. I don't know what to do with this, but I don't think you need to doctor this code either. So you just need to work with the BKY file, and
My guess is
done.
that when you edit stuff in the block editor, this gets generated.
Yeah.
So the system doesn't have to regenerate at that time.
All the time, right. Well, we're running out of time today, but if you guys want to stay just a little bit longer, I can test this, right? Just create a new project, test. How should I put this? I'll call it Frankenstein. Yeah. Which is not surprising because MIT and Berkeley are the two schools which use either Scheme, which is a dialect of Lisp, or Lisp itself in their introduction to programming class. Yeah, they don't start with C++ or Java or Pascal. They start with Lisp or Scheme.
The name
Huh?
You start with what?
Lisp, L-I-S-P, as a programming language, or Scheme as a programming language. Okay, so what I'll do is I'll go back to projects, go to my new project, Frankenstein. Oops. Check this one.
You probably want to add like a line of code to have something to add to, so you're not generating all the header.
It already has some stuff in it.
Oh, it does?
Yeah.
I didn't think the block editor had anything in there.
It should. Let's check. Frankie. Unzip. Okay. So we go to source, app inventor, AI Frankenstein. We look at screen1.bky. Okay, so it has, that's enough. I mean, that's already enough stuff. So now we need to do some doctoring. So we go to temp, serialize, src, bky. Locate that block that we want to copy. But it has references to stuff that is missing here,
Yeah,
so we need to go to
reference in the screen cannot be copied over unless it already exists.
Yeah, so we'll go for the other subroutine. I think escape should be fine. Go line 76, and we are looking for the end of this block 76 to here. Okay, so now we have the new file created. Now we can go back to this one, and we can say read from temp under the card, escape. So I just transplanted a block from one project to this block to this project here. And if you want to do some additional processing, you can also do some processing about the X and Y. In other words, this one is kind of all the way to the right-hand side because of the X coordinate. So you can fix that too if you want to, but it's not needed. I mean, you just scroll it a little bit to find it. Okay. And then we go back to the source folder here, and then we zip the whole thing back up to its original content. So we say zip in the parent folder frankie.aia and everything in here. Oh, okay. I know why. I didn't specify recursive. There we go. Okay, now we can rename the file from test.zip to test.aia and then upload it here and see if it works. So we say import test.aia and it automatically opens a new project too. So we go to lock screen and we got it. So the transplant was successful. The creature lives. So are there any questions about, all these, kind of tricky stuff that you can do? No questions? Yep.
What is the second language that they use to protein MIT? Lisp, and what's the other one?
It's called Scheme, S-C-H-E-M-E, which is a dialect of Lisp.
S-C-H.
E-M-E.
Are those high level or low level languages?
High. Very high.
And what do they expect the student to have learned in high school? They teach the languages in high school.
I don't know. I don't know what language they teach in high school. Does anyone know? Probably C++ or Java. I mean, that's my assumption. Or Scratch.
They have like left simple and they use like Dreamweaver and stuff.
I don't like Dreamweaver at all. Yeah. Well, first of all, Dreamweaver itself is not a programming language. It can spit out some code to do certain things on a web page, but generally speaking, that kind of code is very brittle, which means if you go to the code generated by Dreamweaver and you do something to it, Dreamweaver itself will not be able to recognize that again and do any further editing. You'll just go, okay, my code has been touched. Okay, it's yours now. I'm not going to do anything with it. So anyway, so I'm hoping that this may be useful to some of you, just because, you need a way to serialize, the strings and the text and list and stuff like that. The other application of this, I'll take this one. The other application of this serialization and unserialize is to store things on a server. Okay, because if you want to store something that's complex, onto a server, this is one quick and easy way to do it. Because internally, you probably want to use a list to represent something that is complicated, and then this is a quick and easy way to turn it into a text representation. Use the post method, send it out to the internet, store into a database, and now you have the complicated thing stored remotely into a database. To retrieve it is to retrieve a single string out of the database, get it back onto your application, unserialize, and then now you have the entire complicated data structure back. Because in that case, the list does not export correctly either. Okay, you cannot just stick a list into the post. It doesn't work. But if you first convert it into text, then it should work just fine. So there are definitely applications of something like this if you need to store a complex data structure somewhere else, but only as text. Okay. All right. Well, we are running out of time today for the lecture. I'm going to stop the recording here. I will stay here to answer any questions about your project if you're running up against some kind of limitation or a block of some kind. Just keep in mind that I have a